So it's really important that regular maintenance be done to make sure that the capacitors are still in good condition. So power factor correction equipment doesn't just reduce your electricity bills, it also reduces transmission losses. Hi, my name is Eric. I'm from Alpha Power Solutions, and today we'll be talking about why regular power factor correction capacitor maintenance protects your bottom line. So when an investment is done in power factor correction solution, it's critical that the equipment keeps being maintained so that the returns or the savings being achieved from the power factor correction equipment is achieved. In general, good capacitors should last at least 5 years before they need to be replaced. So it's normal wear and tear. There's every single brand of capacitor will deteriorate gradually over time. Some will deteriorate faster than others, depending on the brand, depending on the thickness of the film. There's a number of factors that affect the life expectancy of capacitors. But typically what you will see is that as the performance of the capacitors drops down, reduces, it will typically achieve a knee point at about 85% performance. And past that point, the life expectancy of the capacitors is then pretty short. So it deteriorates very slowly until it achieves 85% performance and then usually just collapses from there. So it's really important that regular maintenance be done to make sure that the capacitors are still in good condition, and they're replaced before it's too late. So the frequency of the maintenance really depends on a number of factors. Typically, it's going to be dust or other contaminants that are in the environment in which the power factor correction equipment is installed. Vibration can have a negative, excessive vibration can have a negative effect on the life expectancy of capacitors. Poor power quality, voltage surges typically will reduce the life. Harmonics, if they exceed certain levels, will reduce the life. And elevated ambient temperatures. So the higher the operating temperature in which the PFC equipment operates, the shorter the life expectancy. And the reason for that is quite simple, is that the key component within a capacitor is the plastic film that's basically the core of a capacitor. And the higher the temperature, the quicker that film will reduce it. Keeping everything cool, well ventilated is absolutely crucial. Good quality capacitors typically have overpressure disconnect switch built into them. Basically what happens is that as a capacitor starts to fail, there will be gas produced inside the capacitor canister. With time, that pressure will be reaching a point where either the crumble zone that is built into the housing of the capacitor elongates to cut the internal connections, or the lid of the capacitor pops up. Either way, it's quite easy to see whether or not a capacitor has a failed overpressure system. Whenever the capacitor has disconnected itself, it needs to be replaced. It cannot be fixed, it just needs to be replaced. On some capacitors that are, especially the ones that are mounted inside steel bins, it is possible that the capacitors, when they failed, actually created a hotspot with a very high temperature. And that can then lead to burn marks on the outside of the canister to become visible. And lastly, a quick check is the verification whether or not the fuses protecting the capacitors have not failed. Typically, fuses nowadays have an indicator that pops out when the fuse has failed. When a fuse has failed, you must always check the whole system, because the fuse failed for a reason. Some people then replace the fuses and hope for the best. Well, the fuse failed typically because the capacitor has failed. Replacing the fuses without replacing the capacitor makes no sense. And when we do services, obviously we energize the capacitors and we measure the current on all three phases for each capacitor. And we compare, so we get a reading, a certain current, and we compare that reading to what is expected to be achieved from that capacitor. And if that variance is more than 15%, then we do recommend the replacement. So that is a fail-safe system. It's much more effective in determining the health of a capacitor instead of just measuring the capacitance of the capacitors. Energizing them is basically the true proof whether or not the capacitor is performing or has deteriorated beyond the point where it needs to be replaced. So the regular maintenance of a power factor correction equipment reduces the risk of the power factor correction system failing completely. Power factor correction equipment has to work 24/7, 365, especially when the factory or the plant is in full operation at its peak load, when it's drawing the most power in a typical 24-hour cycle. If it's not operational at peak load for more than 30 minutes while the factory is at full production, it will result in a significant increase in energy costs or electricity costs at the end of the month. The trick is actually to replace components before it becomes a major problem. You see, what happens is that if you have a power factor correction system that is well designed and is taking care of the requirements of the factory, one of the steps were to fail, say the capacitors on one of the banks fail, it won't have a significant impact, because when you close to a unity power factor correction system works properly, if you lose one bank, you typically don't lose, or the power factor of the plant doesn't drop that dramatically, because it will just initially just gradually drop the power factor. So immediate interventions to repair these components or the failed components when one of the banks or the steps or the PFC panels fail is not really required. But if you let it slip, if you allow more and more banks to fail, then obviously it's going to have a significant impact on the electricity costs. Our recommendation is always, if it's major repairs, they need to be done as soon as possible. But if it is just a minor thing or a deteriorating capacitor, what we typically then recommend to our customers, listen, let's leave it as it is, but when we do the next service, let's just replace these components at the same time. That usually works very well, rather than having a separate call out to go and repair a minor defect. So that's typically what we do. First of all, obviously the quality of the capacitor, and that typically relates to the thickness of the polypropylene film, the plastic film that's used to manufacture the capacitor. The operating temperature in which the power factor correction system sits, that's another big factor. Typically, good quality capacitors can work effectively in temperatures up to 55 degrees. Once that starts exceeding that, you have a dramatic reduction in life expectancy of the capacitor. So the colder it can, the better ventilated the power factor correction system is, the better the life expectancy that you're going to get. Vibrations can cause mechanical damages inside the capacitors, so that needs to be watched. Elevated harmonic levels, especially in systems where there are no power factor correction systems, where there's no harmonic blocking reactors installed. Voltage surges. Capacitors represent a low impedance path for voltage surges. When they enter in from the supply, the voltage surges will be attracted towards the capacitors in a power factor correction system if they're not protected by surge arresters. So there's a number of factors that would determine whether or not the system is susceptible to be damaged by voltage surges. Another factor is the number of times a capacitor is switched on and off. So what happens is that capacitors really don't like a change of state. So what I mean is they don't like to be switched on and they don't like to be switched off. When that happens, there's a certain amount of back EMF that's being generated. Even though you have pressers or snubbers on the switching circuits to alleviate those surges, each cycle or each switch on or off will result in a minor deterioration of the power factor correction panel. And when it starts running in the tens and the hundreds of thousands of cycles, then it will affect the life of the capacitor. The average or the minimum life expectancy of a well-designed and well-protected power factor correction system, or the life expectancy of the capacitors is at least 5 years. But there is no reason that it can't be 10 years and even 20 years. We have seen systems where the capacitors are 25 years old and they're still in perfect condition. But typically you would say you wouldn't expect a failure of a power factor correction capacitor before at least 5 years after being commissioned. Well, the vast majority of the capacitors installed in Southern Africa, we either keep them in stock ourselves, or there is stock kept in South Africa by certain OEMs. And then the lead time is typically 2 to 3 days before we can get the capacitors installed by our clients. Now, in the unlikely event that the capacitors are not available in the country, we have access to suppliers, especially in Europe, who do keep stock. And we can air freight these units in and have them in South Africa ready for installation within 7 days. Whenever there's a shortage of capacitors by a specific OEM within South Africa, we have many ways to find alternatives, good quality alternatives that will be able to fit in whatever application they are required. So worst case scenario, you're typically looking at a 7-day lead time, or a week's lead time. When it comes to medium voltage capacitors and high voltage capacitors, then it's a different story. Nobody actually really keeps stock of these capacitors because there is so many different permutations possible. So they're usually made to order. And typically then, the manufacturing time is usually around 16 weeks, and then you still have to add the air freight or the sea freight. So for medium voltage, it's slightly different. Well, thanks for watching. If you found this helpful, please like and subscribe. There's a blog with more info linked in the description below.